What's up? What did somebody say? Okay. So, we're working. Well, I thought I heard my name, but then. Okay, because we're recording, so, time sensitive. Yeah. All right. Later. All right. So, when you're dividing stuff, if it doesn't go evenly, you know that you add whatever your remainder was over whatever you divided, right? That's all that this is saying, okay? It's like big and long and weird and all mathy. Don't worry about it, okay? You just have whatever it goes into and then plus your remainder over what you divided in the first place, which is what we're going to do with these. So, shortly we're going to get to synthetic division, but right now we're going to do long division just to remember how to do that, okay? And all of this is to help you find your real zeros of polynomials, so it should be reviewed. We've done this before, right? Yes. Okay, good. So, when we're doing long division, we've done that, right? Yes. Okay, so we didn't just skip straight to synthetic division? Okay. I really like long division better, which is like weird, but I so much prefer it. So we're going to do that first. So you've got to make sure that your exponents go in descending order. If you're missing something, like if we didn't have the x term, you put 0. Yeah. Same thing applies when we do synthetic division later. So we're going to divide by x minus 4, so that goes on the outside. Do we need to remember how to do long division with just numbers first? Are we good with just numbers? Like if I'm like, hey, do 7 divided by, or 38 divided by 7. Oh, wait, I think I remember how to do it. And then you do like 7, how many times? Right? Do we need to like review that? Maybe? Are we good? Yes. Oh, okay. So, we're assuming we're good here. If we're not, I'm sorry. So we've got 6x squared minus 26x plus 12. All right, so we're thinking, what do we have to multiply x by to get to 6x squared? 6 squared. I mean 6x squared. So if we have to multiply by 6x, that's going to go right here. So then x times 6x gives you 6x squared. Because you're just keeping it lined up with like the same terms. So like, it's an x over an x. So that's just 26. I mean, it doesn't really matter, but it just looks better that way. Okay, that's fine. I don't care where you write it. Okay. So, but like, did you write it over here? No, she wrote it. Okay, that's fine. That's fine. All right. That would be the right-hand side anyway, not the left. Anyways, negative 4 times negative 6 is negative what? Is that okay? So then you subtract those. Are we all right? 6x times negative 4. Oh, I forgot to use that number up there. Okay, so backtrack. What x times what gives you 6x squared? 6x. That's where that 6x came from. Is that okay, Brody? Yeah? Okay, because you were like, where did that come from? And I just explained it, and then you said that wasn't. So, are we okay? So 6x squared minus 6x squared cancels out, yeah? So that part goes away. Then you've got negative 26 minus negative 24. Negative 2. Right? When you minus the negative, you're adding. So that's like negative 26 plus 24. That's going to give us negative 2x. Wait. Why is it not? Because negative like 50. Because it's negative 26 minus negative 24. That's why I use parentheses right there, so that we don't forget to subtract everything. Then what do we do from there? Bring the 12 down. So now we're thinking x times what gives you negative 2x. So that's where we put a minus 2 up here. So then x times negative 2 gives you negative 2x. And negative 4 times negative 2 gives you... And remember, subtracting that whole thing. So negative 2x minus negative 2x, that's going to cancel. 12 minus 8 gives you 4. So your remainder is 4.
And don't you, like, if you put it on there, you put plus 4 over
Yep, so when we write our final answer, we're going to write what you had up top. So 6x minus 2 plus your remainder, which was 4, over x minus 4. Got it okay? That's why we're spending time on it. Questions? Okay, so let's do one more. So this time we're doing all of this by all of this. So we've got 2x squared minus x plus 2 divided by. We've got 8x to the 4th, but we don't have an x cubed, so what do we need to put? 0. Then 6x squared minus 3x plus 1. Oh, we didn't finish the first one. Alright, are we okay to start dividing? So 2x squared times what would give you 8x to the 4th? 4x squared? So 2x squared times 4x squared is 8x to the 4th. Negative x times 4x squared. Cubed. And then 2 times 4x squared. Is that okay? So then 8x to the 4th minus 8x to the 4th, 0 minus negative 4, so that's going to be 4x cubed. And then 6 minus 8x squared, or 6x squared minus 8x squared, so negative 2x squared. And we'll bring down the negative 3x. Is that okay? Do we have questions?
Yeah, why didn't you bring it on the one?
Because we only have 3 terms here, so we're just not there yet. Any other questions right now? Alright, so next we're thinking 2x squared times what gives you 4x cubed? 2x. So we're going to have 4x cubed minus 2x squared plus 4x. And remember, we're subtracting all of that. So the negative, or the 4x cubed cancel, the 2x squared canceled, and you have a remainder of negative 7x plus 1.
So that's your whole remainder.
Is that okay?
Yes.
Does your remainder have to be just like a constant?
I don't know.
No, that's totally fine, okay? So that's our remainder. So if we're writing like our answer there, it would be 4x squared plus 2x. I'd usually do plus and then keep my negative with that over the number we divided. 2x squared minus x plus 2. Is that okay? Are we good with how to write our answer after the division? Yeah? Okay. So what we can do from there, and that's what this part is saying, you can rewrite your function after you've done that division as like products of factors. Does that make sense? So that might be like helpful when you're trying to find all your zeros and stuff. So like for this one, we could multiply these two and then add 4 because that was your remainder, and that would be the same thing as what we started with here. So when you write that, it's going to be f of x equals the x minus 4, 6x minus 2 plus 4, that was your remainder. Is that okay? So I'm going to slide down for just a second. That's what this is saying. Okay? So I don't know if you wrote that down or not, but that's all that's telling you to do. So it's just another way to write your function. Well, when you write this, that's just your answer after division. This is your whole function. So this might be more helpful later. It just depends on what they're asking for. Okay. So we'll do the same thing with number 2 over here. So we'll take our factors that we can multiply and then add our remainder. So your function is 2x squared minus x plus 2 times what we got up top. So that's that 4x squared plus 2x. And then you'll add your remainder, which was negative 7x plus 1. I'm going to put parentheses around this just so we know that that was your remainder and that's where that's coming from. They don't really mean anything, but just to help you see it. Is that okay? Questions? So when we do synthetic division, it's essentially the same thing. It's just quicker, right? So you remember you have to like pick a number to put on your shelf. So they're going to give you a factor, and you just switch the sign, and that's the number you put on the shelf, right? So if we were looking like at this one, switch the sign, you put a 4 on the shelf. For the example that we're going to do, they're giving you the factor x minus 3. So what are we going to put on the shelf? Positive 3. So then, again, if you're missing any of your exponents, like going down, you put a 0 as a placeholder. So we've got 2x cubed, negative 7x squared. We don't have an x, so you need a 0 as a placeholder. And then we've got a positive 5. Is that okay? So again, this is going to get you to the same place. It's just, some people think it's easier. It's certainly less messy. So, do you remember how it works? And then you do 3 times 2 is 6. And negative 7 minus 6. Is that how that works? Or do you add? You add, don't you? You add. So negative 7 plus 6. Negative 1, and then multiply. Negative 3. Negative 9, negative 4. Is that okay? So remember the last one is your remainder. So then how are we going to like write our answer? What does all this stuff mean? How do you know to start with x squared?
Because it's 1 less than the term.
Do you remember that? You always start 1 less than whatever your first one was. So we'll have 2x squared minus x minus 3 plus 4 over x minus 3. That would be like our answer from division. Then we can get... then we'll go back and write our function like we did on these two up here. We'll do the same thing. So we divided by x minus 3. Are we okay? Questions? so that's just helping you remember how to divide and whatnot. You'll probably use synthetic division most of the time, right? Okay, so we use that to see if stuff is actually a factor or not. Okay, so the next part is talking about the remainder theorem. So when you divide by that factor, if your remainder is 0, that means it is a factor. Does that make sense? We've talked about this before? Okay, great. So, yeah, we're just going to go through with these. So, what does it want us to do? Find the remainder of this based on these guys. So, did we read this? So, if the polynomial f of x is divided by x minus c, then your remainder, r of x, is the value of f of c. So, when we do f of 3, whatever we get as our remainder, that's what that would be. So, like, when we said if it's 0, it's a factor, those are like your roots, right? Because it happens at the x-axis when it's 0. Yeah. So then if we get something else, like negative 14, that means that if we plugged in 3, you would get negative 14. So that's another way to do that, which I'll show you in a second. So if we have x minus 3, what is your c value going to be, or what are we putting on the shelf? 3. So we'll put 3 on the shelf, and then we'll do synthetic division. So we've got 1, negative 4, placeholder for x again, so 0, and negative 5. Is that okay? So bring down the 1. 3 times 1 is 3, negative 4 and 3. Negative 1, negative 3. Alright. So we get negative 14 as a remainder. So what I was saying is, like, if we did f of 3, let's check that over here. So I'm going to do f of 3 real small. So that would be 3 cubed minus 4 times 3 squared minus 5. So 3 cubed, what do we get? 3 cubed. 27. 3 squared. 9 times negative 4. Negative 36 minus 5. So 27 minus 36 minus 5, what do you get? Negative 14, which is your remainder, so it's the same thing. That's what I was saying, or trying to say earlier. Yeah, no, maybe. Alright, so we did the division. We just want to find your remainder, isn't it? So we'll go ahead and like write our answer too, just because I feel like that would be a good thing to do. So we'll have x squared minus x minus 3 minus or plus negative 14 over x minus 3. Is that okay? Questions on any of that? Okay, cool. So we're doing the same thing with the next one. This time they're giving you x plus 2. So what do we need to put on the shelf? You're using the same polynomial again. So we'll have 1, negative 4, 0, negative 5. And we'll do that synthetic division. First one. Alright, so all we had to do was find your remainder. We already did that. Do we want to go back and like write what our answer would be after division, or not worry about it? Not worry about it? Okay, so are we good? Are we okay? Is there anything we're not sure about, don't understand, have questions? Okay, cool.
Do I take a little chair or a little grid box?
I think that this is what I was trying to say earlier. So when you do synthetic division, your factor theorem just says that your remainder needs to be 0. If the remainder is not 0, it's not a factor. But we said we knew that already. We've talked about that before. Okay, so that's all that's saying. I can't spell has. Use a factor theorem to determine if this has a factor. Yeah, I made this. It took a lot of time too, so you better appreciate it. Okay. So we're gonna do that and just see if these are factors of this one. So what are we gonna put on the shelf right here? If they're giving you x minus 1, put 1 on the shelf. So we're gonna have 2, negative 1, 2, negative 3. So what did we get for our remainder? 0, so what does that mean? This is a factor, so we could say x minus 1 is a factor. Cool. So then you could rewrite that again. Do we need to do that? No. Okay, cool. So we won't. Then for the next one, they're giving you x plus 2. What do you put on the shelf? Negative 2 goes on the shelf. It's 2-5 classwork. What am I doing? That's definitely. I'm just saying. Trust. So your remainder is negative 27. What does that mean? It's not a factor. Are we good with all that? Yes. Okay, wonderful. Here's a whole lot of stuff that you might want to write down. Read it, see what's pertinent information to you, and write that down. Does that make sense? I'll show you what I highlighted as important, like when I did it. So I think we'll just read this. So consider your function, blah, blah, blah. Multiplying out the factors you get, blah, blah, blah. So where did the constant 24 come from? We talked about this already.
When you FOIL out the first two and then you box it, and the last two, it comes from the little bottom.
So how can I go straight from here, not FOIL, and get 24?
You just multiply. Oh, you put a 0 in there. No, you multiply 4 times.
Yes, sorry, I was like, wait. Yeah, put a 0 in for x's, in there for x's. So negative 2 times negative 3 gives you 6 times 4 is 24. Yes, that's where that's coming from. I think I told y'all that last week, right? We were talking about that for your y-intercepts already. So the constants of the factors multiplied out gives your constant p of x, blah, blah, blah. If the product of the zeros equals the constant, the zeros are all factors of the constant. So that's the way to check it. Does that make sense? So if you multiply that out and it checks here, then it works. Probably not going to do that, to be honest. So then your rational zeros theorem. So if the polynomial p has integer coefficients, then every rational zero of p is of the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. You're going to need this, okay? Because you're going to be given a big, long polynomial, and you've got to find all the zeros. So you have to test, see where's I need a number to put on the shelf, because you got to do synthetic division, but you aren't given anything to put on the shelf. You have to find it. So this is the checking process that you go through. Okay, so and p is a factor of the constant, q is a factor of your leading coefficient. So you're going to find all possible p values, so all your factors of your constant, and all the factors of your leading coefficient, and make ratios that are p over q. So one or more of those ratios will be the zeros of your polynomial. Again, you'll do synthetic division to check that. So you'll only want to do synthetic division with the ones that are zeros, so to like double check it real quick, you can do P of whatever ratio. If you get 0, then you know synthetic division is going to work out. Does that make sense? It'll come out nicely how we want it to. So I'll give you all a chance to write that down. The next it says, once you find your 0, you'll use synthetic division to reduce your polynomials into factors. So you may have to do synthetic division more than once, like maybe up to 3 or 4 times. Then you'll keep following the process until you reach a quadratic factor, then try to factor it from there. It's not always going to factor quadratically, so you may have to do the quadratic formula, like it doesn't factor out nicely. Yep. Is that okay? So you know, I'll jot that down, whatever you need there. And then we'll try that with the next one. The next 2, actually.
Yeah.
We got enough down for that? Are we ready to try some? Yeah. So we're given a polynomial. We want to list the possible zeros, find the real zeros, and then factor it completely. So that's like a lot of what they're going to be asking you to do on this test coming up, okay? By the way, you're going to have a quiz on Thursday, so we're having 2 quizzes in this unit. Big quiz on Thursday. And it's not multiple choice, so you're going to have to like show all of it, okay? So to list all our possible zeros, that's your P's and Q's, okay? So our P, again, is your factors of the constant at the end. So we'll say factors of 6. So I'm going to go ahead and write that out. P is -6 for us. And then what is your Q going to be? Your leading coefficient, so ours is 2. So then we're going to make the list of all those ratios. So it'll be, well, we'll make our list of factors first. What are your factors of 6? 1, 2, 3, 6. I put plus or minus in front because we can go either way, right? Yes. And then for your factors of 2, what would they be? We're all right with that? Okay, so now we're going to start making our ratios. So it's kind of tedious. And so all of these again could be positive or negative. That's why we're putting out the plus and minus out front. So if we have 1 over 1, what do you get? 1. If you have 1 over 2. 2 over 1. 2 over 2. 1, we've already got that. 3 over 1. 3 over 2. 6 over 1. 6 over 2. Which we've already got, so we're done. Is that okay? Do you understand how we got all that? So those are all your possible roots. Is that okay? So when I ask you to list all your possible roots, that's this. If you do we not all have calculators? I would grab yours if you don't have it real quick because we're going to be crunching some numbers. Yes, please.
So I'll put the ones that have zeros and have the missing. It's still missing as of right now.
So once you have your list of all possible roots, we need to find the ones that are real zeros. So this is this step right here. We're going to take these, plug them in until we find one that gives us 0 out. So what's probably going to be the easiest number to plug in? 1, right? So we'll have 2 plus 11, which is 13 minus 7, and 6 minus 6 gives you, so what does that mean? 1 is a real root, or a real 0. So we can put it on the shelf and do synthetic division. Yeah? Okay? Well, if you plug in 1, so I'm going to write what we just did. We said f of 1 gives us 0, so we're going to put 1 on the shelf. Does that make sense? I may not need to write that off, but okay. So we're putting 1 on the shelf. We've got 2, 11, negative 7, and negative 6. What did I do wrong? I multiplied by 2. And I have a white out. I multiplied by 2. I goofed. I'm fixing that. So that's just going to be a 13 right there instead of 26. I think I was looking at the 2 beside of it and I was like, oh, times 2. So again, that's going to put a 13 right there, which will put a negative or a positive 6 here. And then that'll put a 6 here, which gives us a 0 as our remainder. This is not dry. That's a 6. Can you tell? No. X minus 1. Yes. Okay. So that's going to give us what? Is that okay? Yes, no, maybe? Okay, so then from there, you need to factor that, right? Can I tell you what it factors into? Is that okay? So, we're just going to find your real 0 So our real zeros are going to be what? We got 1. What else? -6 and... That okay? And all of those came from this list, right? So if you get something outside of this list, you've done something wrong. Yeah? So we got our real zeros, then we need to factor it completely. So we've got those two, and we'll add in a factor from the 1. So what factor would give us 1 to put on the shelf? I think that's what we were talking about earlier.
Oh, shoot.
So, x minus 1. That should all be written like together, but I ran out of room. So here we are. Okay. Do you have questions? It is a lot of work. Is there anything you're not sure about or not quite understanding? Okay, so let's do one more. Alright. So this time we've got 3x cubed plus 4x squared minus 7x plus 2. So we're going to go do all the same things. So we need our p, which is our constant. What is it this time? 2. And then our q is your leading coefficient, which is 3. So your factors of 2 are what? 1 and 2. Your factors of 3 are 1 and 3. So when we make our list of ratios, we got p over q. So you're going to have plus and minus. You should be plus and minus as well. 1 over 1 gives you 1. 2 over 1 gives you 2. 1 over, wait, did we do this? 1 over 1, 1 over 3. 2 over 1 and 2 over 3. Oh, I goofed. Don't hate me. I wrote this wrong when I made the notes. This doesn't work out. Try, sorry. I forgot I wrote it wrong and I had to fix it last semester. This needs to say 3x cubed plus 4x squared. Yeah, I'm sorry. It's supposed to be, minus 7x minus 12, not plus 2. Big difference there. So our p this time is 12. What?
I mean, not squared. It says plus 4x
Squared. Thank you. Sorry. So plus and minus. Your factors of 12 are going to be 1, 2, 3, 4, 6, and 12. Is that okay? Then your q is still 3. So 1 and 3. Alright, then your p over q's. So 1 over 1 is going to give you 1 over 3. 2 over 1. 2 over 3. 3 over 1. 3 over 3. 4 over 1. 4 over 3. 6 over 1. 6 over 3. We got that. And then 12 over 1. And 12 over 3. We got that. Alright, so then from there we want to plug in and see which ones when we plug it in will give us 0. So again, the easiest is 1, right? So we plug in 1, that's going to be 3 plus 4 is 7, minus 7 is 0, minus 12 is -12. So does 1 work? No. So 1 is out. Does that make sense? So we won't use 1. I'm going to label this as all possible roots. So then you'd have to just keep plugging in until we find something that works. So give me 1 moment. I'll show you something that does work, so we don't have to go through that process. Don't mark it as a 0 yet. We'll mark it as a 0 because most of them didn't do it. So we're gonna go with I think it's gonna be 2/3. Why is this not working? Okay. Oh my gosh, I read it wrong again. We're gonna be done. We're gonna be done. Don't worry about number 2. We won't do that one because I keep goofing and it's my fault. It's supposed to be 3x squared. I wrote it really big, 8x squared, and I wrote 4 again here. So that's not gonna change anything, but well, I think we can fix it right here. 8. I've got to change my master of these notes because I keep screwing it up every time. No, because it was only these numbers, but this should be an 8, not a 4. And then 4/3 will work. We can also do -1. We'll do -1. That'll be easier, I think. So if we put -1 on the shelf, do you know how to find real numbers? Not by hand. So you could graph it, right? Any of those roots, that's a number you could put on your shelf. Does that make sense? So, like when you're taking your exam, that's what I would do to save you time. But you've got to know like why that works. Yeah, does that make sense? Which is like if we plug in -1, we get a 0 out, right? So then we know we can put it on the shelf. Yes. So when we go do synthetic division, we're going to have 3, 8, -7, and -12. 3, -3, 5, -5, -12. So 12. So your remainder is 0. So we'll have 3x squared plus 5x minus 12. I don't know if that factors. Anybody know if it factors in? No, good at factoring like that? I'm sure not. So we'll do synthetic division again. This time let's use -3. So we're going to take what we had here and do synthetic division. So really you should like be able to factor it by hand, but at this point I think synthetic division is going to be easier, so that's what we're going to do. Hope that's okay with y'all. So I pulled both of these numbers from the graph. That's just the easy way to get them. Otherwise, you would be plugging in all this stuff as a positive value, as a negative value, seeing which one gives you a 0 out, which again is just very tedious. So that's why I gave you those numbers. So then we need to write our answer. We need to write all our zeros and our factors. So I don't care which one you do first. Can we do? Actually, I do want to do factors first. So what factor would give us x minus 1? Or sorry, would give us -1 would be x plus 1. What factor would give us -3? Plus 3. And then this is going to be 3x minus 4. 3x minus 4. Is that okay? So then all your zeros are what? It's a little messy, but that's that one. Are y'all just ready to practice